Let's take a look at example number 5. We are given a model. This is a very common model. This is how you convert Fahrenheit to Celsius and Celsius to Fahrenheit. Celsius is used mostly outside the U.S. and the United States. With a few other countries use the Fahrenheit as a measure of temperature. So there's a conversion factor here that is pretty much a linear model. So if you look at this model, I think you can easily see clearly that this model actually is the same as C is equal to 5 over 9 F minus 5 over 9 times 32, as you can see. So in essence, this model can be rewritten like this, where you have this in this case becomes the slope. 5 over 9 is the slope if C is your dependent variable. And then the constant term here is this number here, right here. This is your constant term. This is a fixed number. Now, before you even look at the questions and the answers, you can see that we can say that when F changes by 1 unit, 1 degree Fahrenheit, the Celsius will change by 5 over 9. And that is true without even worry about this. And when the Fahrenheit is 0, of course, then the Celsius will have a negative value like that. At the same time, now I'm going to kind of forget about this constant term for now. I can also say that F is equal to 9 over 5. If let's say I ignore the constant, 9 over 5 uh, C with all this plus something like, so you can see something like this. When you restructure this with some constant like that, you're going to see that F is also related to C in this way. So you can also see that when C changes by 1 degree Celsius, F will change by 9 over 5. 9 over 5 is 1.8, I believe it's 1.8. I want you to understand these basics even before you go for any examination. In case you see them, then you can deal with them. So let's come back and take a look at the conditions here. The first condition is this: a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5 over 9 degrees Celsius. Is that true? Well, a temperature increase of 1 degree Fahrenheit, so this changes by 1 degree. The C is supposed to change by 5 over 9, and the answer is true, because that is what this model is saying. Let's go to II. A temperature increase of 1 degree Celsius, which means if I have restructured this for it to have F to be the dependent variable, then a temperature increase of 1 degree Fahrenheit should correspond to a temperature increase of 9 over 5 degrees Fahrenheit. The trick is here they gave you 1.8 Fahrenheit. Now you have it here 9 over 5, so you should convert it. This was a little tricky problem. You should convert 9 over 5, and 9 over 5 is 1.8. Take your calculator and check that one out. So if this is true, then you say a temperature increase of 1 degree Celsius, this one is equivalent to a temperature increase of this. That means the slope has to be 1.8, and this is also true. Now let's take a look at this. A temperature increase of 5 over 9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. This doesn't make any sense. This is A that has been reversed, and we know that is not true. It's the other way around. So now let's go back to our questions. It's not just I only, because I is also true. It's not I only, because I is also true. And of course, I is false. And therefore, the answer choice here will be this one. So hopefully you understand how to rearrange this kind of problem. I mean, this is kind of similar to doing isolation of a linear model and then interpret the various parameters that form the model. So, you're always going to get a question like this in the SAT, and I want you to be ready for them. It's pretty straightforward. You should be able to get that without any problems.